So this video is going to walk you through the photosynthetic rate calculation that you're going to need for your lab report. So there is a PDF copy of this available to you on Canvas, but I'm going to walk you through the calculation so you can understand where all of the numbers come from and then hopefully do the calculation for your own data. So the data that we're giving you some example data, and what we're asking for you to do is to determine the rate of DC-PIP decolorization in terms of change in absorbance units. So delta equals change, A621 is the absorbance units per minute per milligram of chlorophyll. So we've got a little bit of information on the left-hand side here. So we can see that the chloroplasts were extracted as per the protocol. The initial concentration of chlorophyll was found to be 1.2 milligrams per mil. So this person diluted their extract down with an additional 1.5 mil of isolation buffer. So there was a dilution in there. We've then got DC-PIP decolorization in the light. So we've got time against absorbance. And if we draw out the graph of that, then it looks something like this. So as we discussed before, we want to take the rates where we're looking at where the majority of the reaction is happening. So in this case, I'm going to take it between T0 and probably T3 here would be a good point. Most of the reaction has happened by T3. This part of the graph here is starting to saturate off. Okay, so there's a few different steps we need to do this calculation, so let's walk through it. Okay, so the first thing we need to do is to deal with this information here to work out the actual concentration of chlorophyll that we use. So at the moment we've got the undiluted concentration of 1.22 mg per mil, but we need to find the diluted concentration. So for this, we've got an equation that we can use. That is V1C1 equals V2C2. So in this equation, V is volume and C is concentration. So on the left-hand side, this is the undiluted on the left-hand side. This is the undiluted, and then this is the diluted. So if I rearrange the equation, what we're trying to find is this C2. If we're trying to find C2, that is the diluted concentration. That's the thing that we're trying to find out in this equation. So if I rearrange it, so C2 equals V1C1 over V2. So I can now substitute in some numbers. Okay, so V1, that is the undiluted volume. So that comes from the protocol. So that's this number here, goes into the equation there. Okay, so I had 1500 microliters to start with. This number here is the undiluted concentration, so that's this number here. And then for the diluted volume for V2, we've got our original 1500 microliters and our additional 1500 microliters, our additional 1.5 mil. So that's the bottom of our equation. So if I solve that equation, then I should get an answer of 0.61 milligrams per mil of chlorophyll. So that is the diluted chlorophyll concentration. So this now allows me to move on to my rate calculation. Now I know how much chlorophyll I actually had, I can go through and calculate my rates. So just to remind you, a rate is defined as change divided by time. That's what a rate is. So what we're going to try and find out is the change in absorbance divided by time over here. So effectively what we're trying to do is to find the slope of a line like that going through our data. That's what we're trying to find with this calculation here. We're trying to find out what the slope of that line is. So first step to do, so first of all let's deal with the change. So the change is the change in absorbance units, so delta equals change. So if I do between time points 0 and 3, then I get 1.670 minus 0.899. So that gives me a change of 0.711 absorbance units in 3 minutes. Okay, so that's how much the absorbance changed in 3 minutes. What I want to do now is to express that per minute. which would be a more usual way of expressing biochemical data. So all I need to do here is to divide that 0.711 by the 3 minutes, and that gives me an answer of 0.257 of change in absorbance units per minute. Okay, so that's my amount of change. So I've got the beginnings of a rate. So I've done this bit, and I've done this bit. Now we need to think about normalising this for the amount of milligrams of chlorophyll. If your extract was more concentrated, then you'd expect it to have a higher rate. So what we're going to do is to factor in the amount of chlorophyll that we had. So for this bit of the calculation, I need to use this formula. So the amount of something, so the number of milligrams, so chlorophyll in our case, is equal to the concentration that we've got times by the volume that we've got. So amount equals concentration times by volume. And we know all of this information, so we can work out the amount of chlorophyll. So we know from the protocol that our volume is 0.1 mil. That was the protocol. If you added a different amount of chloroplast, then you'll need to change that number, but most people should be that 0.1 mil. And the concentration we found out over here. So this was our diluted concentration, so that we can put into that formula there. Okay, so if I do amount equals concentration times volume, so we've got that 0.61 milligrams per mil times by the 0.1 mil, then I get an answer of 0.061 milligrams. Okay, so that's the amount of chlorophyll that I'm adding to my reaction. So now I can just do the last step. So my rate overall is going to be, so my rates in terms of absorbance units per milligrams, so that's that 0.2757 there, goes in there, divided by the 0.61, that goes into the bottom of the equation. So that gives me a final answer, if I calculate that, of 4.21 change in absorbance units per minute per milligram. So that's my final rate value for this particular experiment. So that's effectively the slope of this line on the graph. So hopefully you should now be able to calculate that for your own reactions. So just a note, to pass the assignment, you've got to do this bit. So you have to do your rates of change in absorbance units divided by time. So taking 2 time points and then dividing by the number of minutes. So that's the essential that you need to just pass the assignment. If you want to get good marks on the assignment, you also need to do this chlorophyll concentration. So to normalise by the chlorophyll concentration there, using both our V1C1 thing to get the diluted chlorophyll concentration, and then this amount equals concentration times volume. So there's a few different steps in there. Watch the video a couple of times so that you understand it, and then try and do it with your own data. Substitute your own values into the equations to work out your own rate values, and you should have rate values for each of your time courses. So if you did 3 time courses in the dark, you should have 3 dark rate values. If you did 3 time courses in the light, you should then have 3 light values, and you can then use those rate values in your statistical testing.